questions on homework? If not, we're going to start chapter 1.4. Writing an equation of a line. This should not be new. Y'all have written equations of a line. Algebra 1 spent a good amount of time writing the equation of a line. When we write an equation of a line, or we're graphing an equation of a line, we need 2 points. We normally need 2 points. That's all we need for equation of a line. Quadratics, our U-shaped graphs, need 5. Really 3. Because of mirroring, and we'll see how that works, but 5 points for a graph of a parabola. But we're not worried about those. We're graphing, or talking about equations of a line. I'm not going to make you graph. Now, there's 3 types of equations of a line, or general forms, that we use. We really only use 2 of them. First one is point-slope form. Or not point-slope. Point-slope is one of them. Slope-intercept. Getting ahead of myself. Slope-intercept form. Y equals mx plus b.
Taylor Gomez and Molly Payne, you need to go to the office. Taylor Gomez and Molly Payne, you need to come to the office.
Y equals mx plus b is slope-intercept form. Do you know why we call it slope-intercept form? X and y are the independent and dependent variables. They're just going to be a part of the equation, yes? So the other 2 main parts that we have for this equation are the m and the b value, yes? M is representing what? Slope. B represents the y-intercept. So they called it slope-intercept form because the 2 key components of it are a slope and an intercept. So they literally called it exactly what it is. It's slope-intercept form. We have a slope, we have an intercept, it gives us the equation of a line. The other main form that we have is point-slope form. The main components of it are a slope and a point. They literally called it what it is. Intercept. B is our intercept, our y-intercept. Given as a point is 0, comma b, we're mainly looking at the b value. The y-intercept is the point on the graph where it crosses the y-axis. The x value at the y-intercept will always be 0. The y value at the x-intercept will also be 0. But for slope-intercept equation of the line, we're mainly focused on the y-intercept. Because if I'm given the slope and the y-intercept, we're just going to go straight to this form. We plug in for slope, b is our y-intercept, and we're done. Now, if they don't give us that, they give us a point in the slope. We use point slope. We plug x1, y1, the value of the point, into those. Slope in for m, solve from there. And y'all have done this, especially in Algebra 1. They did not always give you this slope. They sometimes gave us 2 points. And if they gave us 2 points, what we do is we take our slope equation, the formula for slope, y2 minus y1 over x2 minus x1, which is really what? The change in y over the change in x, our rise over run delta y over delta x, the change in y over the change in x. Delta in math just means change. Is there any difference in the 3 things I just, or 4 things I just wrote? No, they're all the exact same thing. It's just different ways to see it, different ways to phrase it. Because if the rise over run is something nice, we can count up and over. Rise over run. change in y over change in x. Because if we're given 2 points, we're going to find the slope and then use point-slope form. That's the best way I would say to do it. Questions on anything we've talked about so far? Now, yes, there is something, a formula called 2-point form. I would not write this down. This is point-slope form, but instead of writing m, I put the equation for slope. It is the exact same thing. Would we kind of agree there's a lot to plug into that thing? Yeah, it's a lot. There's too much. I think it's too much to try to keep track of all at once. When slope is nice enough, y2 minus y1, x2 minus x1, we set it up, we plug it in, we get slope, we plug it into point slope, solve for y, we're done. I think it's easier, nicer to do that than try to keep track of everything. It does exist, it is a thing, we're not going to use it. So 1.4, what we're focused on is finding equations of lines and interpreting things, telling it, or writing out and explaining what we're actually being shown. I think most of the juniors that have Mr. Coffee this year, you're doing that in some of his classes. Points, plots, giving information. Here, the graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of a line and interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that far? Okay, let's see here. We have to write an equation of a line and interpret the slope. Then figure out how far it takes us to travel that distance. This question just asks us to do 3 different things. So we should have 3 answers for this here. 2 of them are going to be a definite answer, and 1 of them can be phrased several different ways. I will explain that one when we get to it. So we need to write the equation of a line, interpret the slope, and then figure out how long it takes it to travel 17,200 miles. Well, if I want to find the equation of a line, I need either the slope and the y-intercept or slope and a point, yes? Do we know what the slope is? No. So let's find it first. y2 minus y1 over x2 minus x1. What is one of the y values, or a y value that it gave us? So it gave us a point, yes? What's the y value of that point? 24. So we can say 24 is the y value, yes? Now, since we use 24, that point, that y value first, it means we have to use its corresponding x value first. 5, 24, y on top, x on bottom. X in a point always comes first, y always comes second. We know why we always do points in xy form. Has that been explained or mentioned? Which one comes first alphabetically? X, yes? That's why it's first. X, Y, Z in order triplet. X, Y, Z, that's alphabetical. According to number theory, we do or order things in alphabetical order and power. Whichever one has the biggest exponent and alphabetically goes first. So, we good with how we've set this up so far? We need a second point, yes? Now, they didn't give us a nice point on here, but there is another nice point on this graph, which is 0, 0, yes? So that means the other y value is 0, and its corresponding x is 0. All right. There's 2 things two different ways we can go from here. One is we calculate it. 24 minus 0 is 24. 5 minus 0 is. Does 24 divide by 5 nicely? No. Now we can turn it into a decimal, which is 4.8, or we can leave it as 24/5. Especially for graphing or actually having to graph it, fractions actually work nicer. Now the other way is 24 minus 0 over 5 minus 0. 24/5, it doesn't reduce for good there. So we found the slope, yes? So we're halfway through finding the equation of the line, yes? Now it did also ask us to what? Find the equation of the line and interpret the slope. Now this might be something new. I'm going to put A just so we know this is part of our answer. Interpreting the slope says we want to look at the slope, so 24 over 5, and see what it means in context of this problem. The y value, the number on top, is associated with the y-axis, yes? And according to the chart, the y-axis is what? Distance in miles, yes? Our x-coordinate, our x values is time in seconds. So if we look at this, so we're 24 over 5. So for every 24 miles, we have 5 seconds, yes? So we could just say, for every 24 miles, it takes us 5 seconds to travel that. Or, which might be nicer, for every, what, 5 seconds, it travels, what, 24 miles. Are you starting to see how this could be written in a lot of different ways? It travels 4.8 miles every second, because 24 over 5 is 4.8, so for every 4.8 miles it takes 1 second to travel that far. Okay? We see how this one varies depending on how we phrase it, yes? Now, well, what if I don't phrase it the way I write, yes? When I look at this one, when interpreting the slope, I look at what are you saying. If what you're saying is still describing the slope, I will take it. You do not have to write it for every 5 seconds it travels 24 miles. You could say for every 24 miles it takes 5 seconds. That is still saying the same thing, yes? For every 4.8 miles it takes 1 second. For every second we travel 4.8 miles. As long as what you say is telling us what the slope is telling us, that is a correct answer. There is not one answer for this. There are many. And as long as it is explaining the same thing, I will take it. Because we could have said for every 10 seconds it travels 48 miles. That still says the same thing, yes? I will not take for every 48 seconds it travels 5 miles. That is not what the slope is saying. So as long as it explains and tells me what the slope is, I will take it. Okay? Questions on explaining the slope or interpreting what the slope tells us? All right. Now we need to find the equation of the line. Now, we have two equations, yes? Y equals mx plus b, and y minus y1 equals m times x minus x1. My big differentiation between which one I use is, do we know what the y-intercept is? Do we know what the value of y is when it crosses the y-axis? Well, yes, it's the point 0, 0 where it crosses that y-axis, yes? So our value of b, the y-intercept, is 0, yes? And the slope is 24 over 5. Because if I have the y-intercept and the slope, we can use what? Slope, intercept, point. So we'll plug 24 fifths in for M and 0 in for B. Let's wake up. Let's wake up. Do we need to, yeah, I think the main thing you're asking is, do we need the plus 0? No, so it's really what? Y equals 24x? Yeah. Do we need anything else? Did we answer all the questions? No, what else did it ask? For how long does it take the asteroid to travel that distance? How long does it take it to travel 17,200 miles? So the last thing we need to do is solve. Now we're going to take the equation we just got, y equals 24 fifths x, and we need to plug 17,200 into one of the two variables. Which of the two is distance, x or y? We can look at the chart. Which one's x, which one's y? Y is the distance, yes? So I'm going to replace y with 17,200. We're trying to figure out how long it takes. So we need to figure out how the value of x. So we need to get x by itself, yes? 24 fifths and x. Are they being added, subtracted, multiplied, or divided? Multiplied, total. Because we're multiplying by 25, dividing by 5, but 24 fifths is being multiplied by the x. So we're multiplying them together. So to undo that, we would divide. So we would divide both sides by 24 fifths. Anything divided by itself is what? Almost up. 1. 24 fifths over 24 fifths is 1. Anything divided by itself is 1. But we also need to do 17,200 divided by 24 fifths is 3,583.3 repeated. We'll just say 3,583. That's close enough. Is that hours? Minutes? Seconds? So it takes it 3,583, approximately 3,583 seconds to travel 17,200 miles. This is just under 1 hour. 60 minutes, or 60 seconds in a minute, 60 minutes in an hour. So if I divided that by 60, we would say it would take 59.72 minutes. Divided by 60 again, it takes 0.99537 hours. Not even an hour. That is stupid fast, yes? Because it takes about, what, an hour 20, hour 30 to get to Tulsa, so we're looking at a little over 100 miles. This says it travels 24 and 5 seconds. So you're looking between, or somewhere close to 15 seconds to get from here to Tulsa. If you drove in a straight line. And you'd really hope that nothing got in your way, because traveling that fast is not going to end well. Yeah. 4.8 miles per second, minute, hour, yeah. You're traveling close to 17,280 miles per hour. Ain't going to end well. But questions on what we did? The graph shows the remaining balance y on a car loan after making x monthly payments. Write an equation of a line. And interpret the slope and y-intercept. So we're going to have to interpret two things instead of just one. And what is the remaining balance after 36 payments? You need to find the equation of a line, interpret the slope and y-intercept, and then figure out what's remaining after 36 payments. So we got to find three things again. Yes, four. Slope and y-intercept. Now, to find the equation of a line, we really need the slope part of it and see what else we need. Slope. Change in y over change in x. y2 minus y1 over x2 minus x1, yes? So what's one of our y values? Because they gave us 2 points this time, yes? So pick one of them. Yeah, 18. Since we picked 18 to go first, its x value has to go first, which is 0. The other y value is 15. Its corresponding x value is 10. Now again, at this point, we can do it by hand or you can plug it into the calculator. Either works. I do not care which one you do. Because if we do this by hand, 18 minus 15 is 3. 0 minus 10 is, I like putting the negative on top. It doesn't matter. Normally we want to try to keep it out front or move it to the top. Either one works. So negative 3/10. 18 minus 15 over 0 minus, not this. Negative 3/10. Both work. So we have the slope, yes? Let's go on and interpret it. So the x, the denominator, is the number of payments, yes? Y is the remaining balance. So we can say for every, what? 10 payments, the balance does what? Negative 3, or we can say goes down 3. And I would almost agree with this. Goes down 3, what? Look at the chart. The balance is in thousands, so it's really not going down 3, it's going down 3. So every 10 payments, it goes down $3,000. Now that seems a little outrageous or a little out of control, but normally, especially on car payments, you're making one payment a month. So for 10 payments, we're saying 10 months. So each month, we're paying a tenth of that. 3,000 divided by 10 would be 300. So you're paying $300 a month. That's actually pretty average. So the car payment's going down $300 a month. Each month, the balance decreases by $300. That is another way to interpret the slope. We kind of seeing that? Different ways to set it up. So that's our interpreting the slope. But we also need to interpret the y-intercept, yes? Y-intercept is where it crosses the, it's 0 over 18, yes? What is it telling me? Because the 0 is our number of payments, yes? But the y-intercept, how many payments have we made? 0. What's the amount? 1,000. So the y-intercept tells us what? The original. Let's write that better. The starting amount, the original amount, is $18,000. Most likely when they printed this book, that was probably the average price of a brand new car. We're probably looking at the average price of a used car. Questions on how we interpreted the slope or the y-intercept? When we interpret it, we're just doing what? Taking what the information is given to us and put it in words. That's really all we're doing. Next, we need to find the equation, yes? Do we know what the y-intercept is? The y-intercept's value is 18, yes? So that means for us, we can do what? Y equals mx plus b. Because we know the slope is what? -3/10. What's our value be? 18. Now we're not going to use 18,000 because the scale is 8 in thousands. So for our slope and our points, we're just going to say 18. Now we do this because it makes things nicer, makes things easier for us to be able to graph and get numbers. Because if we left it in thousands, that means we would also have to have the slope in thousands. So the slope would be -300x instead of -3/10. We put it on a scale that's nicer and easier to look at. We have the equation of the line, yes? Last piece. It asks us to find the remaining amount after 36 payments, yes? 36 payments, is that going to be X or Y? X, it's our domain, yes? Our input value. So we're going to replace X with 36. And now we're going to have to solve for Y, yes? Now, we can go through our order of operations, work it out, yes? Looking at the left side of this here, Y is by itself, isn't it? Looking at the right side, is there a single variable on that side of the equation? No, we have -3/10 times 36 plus 18. That's straight numbers, yes? It's all numbers. The calculator can do it just fine, yes? I mean, yes, we could do it by hand. -3/10 times 36 would be -98, -98/10. Then we can add 18 to it, turning it into tenths. The calculator can do it for us. So it tells us Y is equal to 7.2. So the remaining balance after 36 payments is 7,200. They did give us a chart. 36 is somewhere, try that again. Somewhere around right here. So our amount should be somewhere right there. We can kind of cross-reference and see 7,200, 7,200 is close to the answer. Yeah. Fraction form? That is a good question. So the main reason I took it out of fraction form is mainly in the context of what we're talking about. So for this here, if I told you, especially we'll say this is your car, oh, by the way, after 36 months, you have 36/5 remaining on it, or 36/5 in thousands remaining on it. Do we have a solid understanding what the, well, no. 7.2, and if we move it to 1,000 is 7,200. I have an easier grasp of it there, yes? If we talk about slope, 36/5, I know we're going up or down 36 over 5. We can use the numbers a lot nicer. We're 7.2 for slope okay, we're going up or down 7.2 units, we're going left, right, 1. We can kind of see it, but fractions is nicer there. Here, 7 point. Yeah. Now for the test, especially if there's a number between the two, I will take either. As long as it's the right number, I will take it. Even if it's not the same number I have written down, I will convert it, what my answer is, to that unit or that setup. If it's a decimal, fraction, radical, I will double check and make sure that they are the same. Unless I specifically say fractions or specific form, I'm taking all forms. Questions on this here? Yeah, and they took out a 5-year loan, so it's not bad, not great. Don't take anything over a 5-year loan on a car. Don't do it, because you will most likely go upside down. Do y'all know what upside down on a car loan, house loan, any of that is? Upside down means you owe more than it's worth. So even if they total it and give you its worth, you still owe money on that car or house. So you're paying for something you don't even own anymore. Not good. See where we're at. So, this will be the last one we do today. We will finish this note sheet on Monday. Finish it on Monday. The graph shows the distance Alice hikes in X hours. Write an equation of a line, interpret the slope, and we want to see how long it takes her to hike 14 miles. Might be good to find the slope. They did give us a point. I value is 24.5, X is 7. Or are we given another point? Yes. 0, 0. Yes. So the bigger number does not always go on top. The Y value goes on top. So at this point, most of the numbers, the Y values have been bigger. They don't have to be. So Y2 minus Y1 over X2 minus X1. So I put a Y value on top, it's X value on the bottom. Yeah. No, that's a good question. At this point, it's just been coincidental that the bigger number's been going on top. Now, 24.5 minus 0 is 24.5. 7 minus 0 is 7. We cannot leave it like this. We cannot have a decimal and a fraction in the same thing. It's going to tell us 3.5. We can use 3.5 or we can use 7/2. We'll use 7/2. We're going to interpret the slope for every what? I always do for every 2 hours she travels what? 7 miles. For every 2 hours she travels 7 miles. It does. Do we have the y-intercept for our equation line? I think we have the y value, don't we? The y value of the y-intercept is 0. So we can plug in the slope. So 7/2 x plus 0. We don't need plus 0. It's not adding anything. Funny enough, doesn't add anything. It's just y equals 7/2 x, yes? Questions on this so far? Y equals 7/2 x. That's our equation of line, yes? Last thing it asks for is what? How long does it take her to travel 14 miles traveling at the same rate? Yes? Do we really need to calculate this one? Because what did our interpreting the slope tell us? For every 2 hours she travels 7 miles, yes? So if we double it, do it again, so it would be 4 hours would be 14 miles. So how long does it take? 4 hours. Did we actually have to calculate anything? No. So 4 hours. Because if we did, it would be 14 equals 7/2 x. We divide both sides by 7/2. X is equal to 4 if we went and solved it. But we don't need to. All we did was for 2 hours, it took her 7 miles. We did our next one. 4 would be 14. 6 would be 21. We just kind of worked our way up to it. But that is it for today.